Hello and welcome back to Mr. Walker's Chemistry. This is just a very brief video to introduce you to the laboratory equipment and how to use it. Okay. So in chemistry we will be using lots of different pieces of equipment. Here I've just included a few of the most common pieces that we will use, and I will describe what we will be using them for. So a lot of these things you've probably used in the past, like a thermometer, but maybe some of them you haven't, like a weigh boat, okay? So let's just start here. These are graduated cylinders, okay? A graduated cylinder comes in either glass or plastic, and it is used primarily to measure liquids, okay? You can see that these have some different colored liquids in them. Some of them have plastic bases, some of them have glass bases attached to them, and they have these rubber things on top of them. So they do come in a bunch of different sizes, okay? We have ones that range from 10 milliliters to 1,000 milliliters or 1 liter, okay? And again, they're just used to measure liquid. They are very accurate. Of course, you don't want to use a 1,000 milliliter graduated cylinder if you only need to measure 10 milliliters of liquid. So you have to use the right tool for the job, as with anything. I do want to talk about just briefly about this rubber thingy. A lot of times I've seen students try and use this as like if you need to measure 40 milliliters on this 100 milliliter graduated cylinder, they'll put it at 40 milliliters and then fill to the red rubber thingy because it does slide up and down on here. That's the incorrect use for it, and actually it does not allow you to get a measurement that's as accurate because you can't actually see the 40 line if you put this on it. It's intended to stay at the top, as shown in these graphics here. And that way, if you accidentally knock one over, which will happen in labs and is okay to happen, it prevents it from breaking. So it'll fall over and hit the rubber thingy instead of the glass top, and it just, again, keeps it from breaking. No big deal. Now, a quick note here. When you fill it with liquid, a lot of times you will get what's called a meniscus. You may have heard about this in one of your other science courses, and it just means that you have a slight curve in it, in the liquid, due to cohesion and adhesion. So, for example, let's say I have one of these, and I know they already have liquid in them, but let's say I want to fill it to exactly 100 mils. Well, I'm going to get kind of a curved line. I apologize, my line's not that good. Right there. You want to read to the bottom of the line, not the top edges. Okay? Read to the bottom of the meniscus. And it'll take practice and time, but you'll get that just fine. Secondly, make sure it's set down on the table and that you're looking at it from eye level. If you're trying to hold up the graduated cylinder, I've very rarely seen anybody's hand perfectly steady. So it'll be jiggling around. It'll be very hard to get an accurate measurement. Accurate measurements in chemistry or in any science are extremely important. So it's also extremely important that you set the graduated cylinder down on the table and read it from eye level. Alright, so let's go back up here and let's see what our next piece of equipment will be. Alright, this is a tri-beam balance and the weigh boat. These work in concert or together. So we use scales or a tri-beam balance to mass things. In other words, we want to weigh them. Alright, oops, we've got a typo there. So we want to weigh whatever it is. Now the weigh boat goes in concert with this because I can put a chemical in the plastic weigh boat, which is disposable, put the weigh boat on the scale, and that way I don't get the scale dirty, I don't have to clean it off. It also makes sure that I get nearly 100% of whatever I'm weighing into the next vessel, the reaction vessel, such as a beaker. Alright, so to use this balance, I'll demonstrate in class, but really, it's got I don't know if you guys can see this or not because this picture is a little bit fuzzy, but there's a line right here and there's a line right here. And what that line does is tell you when you're balanced. So you want to line up the lines. Initially, when you have nothing on it, it should have a weight of 0 and balance out accordingly. So you move all these sliders all the way to the left to indicate a weight of 0 and make sure that these line up. Then you'll place your weigh boat with whatever you're going to weigh on the balance, find out how much it weighs, and go from there. Again, I'm going to demonstrate this in class just so that you're familiar with what I'm talking about. All right, next we have a beaker. These are used also to measure liquids or to contain a reaction, so you can mix things together in a beaker. These are not accurate for measuring liquids, though, not like the graduated cylinder. Graduated cylinder is very accurate. However, you can see that these generally have very large increments. The larger the increment on a measuring device, the less accurate it can be. So if we look at this 2,000 milliliter beaker back here, which is really quite large, and I don't think we'll be using anything that big, you can see it jumps in at measurements of 200 or 400 milliliters here. Okay, that is not going to be accurate if you're trying to measure 150 milliliters of liquid, or even 500 milliliters of liquid. You're going to be off by quite a bit. And for those, you want to use some of these smaller ones. In class, we have ones as small as 25 milliliters all the way up to the 1,000 milliliter. I don't think we have any of these larger ones. I do want to say that for anything that you're using that is larger than 400 milliliters, make sure you're using 2 hands. Okay, glass is slippery, especially when wet, and if you've been measuring liquids into a beaker, then you may get some on the outside and it may be slippery. So for those things that are a little bit larger, just use 2 hands just to be safe. You don't want to drop something that has a dangerous chemical in it on your foot. If it breaks, then you've got the chemical on you. If it doesn't break, it's still going to hurt and you're going to spill the chemical onto the floor. So let's try and avoid that. All right. While I'm here, I've decided to introduce the glass stirring rod. These are just glass rods. They are, you know, what you would expect, and these can be used to stir things in beakers. What I don't want you to do is pick up the beaker and try and swirl it around. You can see that these edges are not designed to contain liquid inside of it if you're moving the liquid around. So if you start swirling and you've got one that's quite full, like all of these are, it's very easy to spill some out, and then of course it gets onto your hand, the table, your work, etc. So just go get one of these. We've got tons of these glass stirring rods. Put it in there and stir it up like you would a pot of boiling water or anything else. Okay, next we have the thermometer. Simple enough, standard thermometer used to measure temperature. On most of our thermometers, you'll see both Fahrenheit and Celsius measured. While you may be most familiar with Fahrenheit because that is what we use in the empirical or English system for our temperature of, like, say, you know, it's 80 degrees outside. We would assume that the person means 80 degrees Fahrenheit, not 80 degrees Celsius, which would be extremely hot. But in science, we use Celsius. So for any labs that you're doing, you want to record things in terms of Celsius. So if you're measuring the boiling point of water, I don't want to see 212. Okay, that's Fahrenheit. I should see 100 degrees Celsius. And these are marked by degree C and degree F at the top. The way that this picture is oriented, you can see that it is in degrees Celsius because we have degree C at the top. Next, we have what's called an Erlenmeyer flask. Erlenmeyer flasks look just, you know, they don't look like beakers, but they are similar to beakers in that they're used to measure liquids or contain reactions. Just as the beaker, these are not accurate for measurements. Do not use it for measurements, okay? That's not what it's for. This is used instead to simply mix stuff with. Now you notice that these have sloped sides and a narrow top. The reason for that is a couple of things. One, if we want to put a stopper in it, we can. There are little things called, like a cork. Okay, we can put a cork in this, and it will contain the reaction. Secondly, if I start stirring this, if I hold it up and I shake it a little bit, it's unlikely that any liquid will actually come out through the top. And so that makes it a lot easier for doing reactions. You do not need to necessarily use a glass stirring rod with these. And again, anything big, hold it with 2 hands. So if it's bigger than 500 mils, use 2 hands when necessary, if possible. Otherwise, just don't pick it up. Just leave it on the table. It's not going to hurt a whole lot. Okay. And I've already talked about weigh boats and glass stirring rods as they are paired with other things. Lastly, I'm just going to talk about chemicals. We will be using lots of chemicals in chemistry. That's where it's fun, right? Okay. So, chemicals. I bolded this entire thing because it's extremely important that you read all of this. I'm not asking you to memorize it, just read it. Okay? Dangerous chemicals are dangerous. Every chemical has the potential to be dangerous. Even table salt, sodium chloride, NaCl, all right, can kill you if you ingest too much of it. Things, even water, something as essential to life as water, can kill you if you have too much of it, or, of course, if you drown in it. There are other chemicals that in very, very, very small amounts, even if they're not super concentrated, can be dangerous. There are others that in even smaller amounts, when concentrated, can be very dangerous. We will be using some of these. All right. Each lab, okay, a briefing will be given. I will tell you, okay, these are the chemicals we're going to be using. For example, today we're going to be using 6 molar hydrochloric acid, combining it with water. Okay, that can be a very dangerous reaction if not done properly. So I will show you how to do the combination, as well as how to handle the hydrochloric acid and water accordingly, so that you don't burn yourself or produce too much of the gas that will be produced from that, or heat even, which could be a problem. All right. It is imperative, very important, that you pay attention to what I say and show you. All right. If at any point during a lab you are using a dangerous chemical incorrectly or improperly, you will not receive credit for the lab. You must follow directions. All right. So there's just a brief introduction to all the laboratory equipment, or some of the laboratory equipment, I should say, that you will be using in class. I hope that this was helpful, and I'll see you next time.